Okay, good morning. Actually, as I told you that this chapter is finished, but I forgot to talk about the derivative of the tangent function, so I will start with that one, and then I will solve some problems from the book, and then you can work on the book yourself, okay? Because there are some problems in the book related to the maximum value and the minimum value, so it means that you need those knowledge from Math 3C. So I will try to solve some of them for you, and if you have forgotten, I will try to find my videos related to those parts and put the links for you here, so that definitely you will get some kind of these questions in the national exam that is related to finding the maximum value, minimum value. Dylan, are you laughing? You're happy? Yeah. Okay. Anyway, so let us see how this goes. The first thing that we want to talk about is the derivative of the tangent. So I don't put any title here, that's just random exercise. Okay, so the goal is to, do you remember we had that table, so I don't want to repeat that table here, but there is one function that we can do it in high school level, and we haven't done that before, and that is the derivative of tangent. We already know the derivative of sine, the derivative of cosine, so it was completely natural to ask what is the derivative of the tangent function. But the tangent function, now we can find the derivative easily, yes? Why is that? Because f of x can be written as a fraction, as a quotient, so it becomes sine x divided by cosine x, yes? And then let me write the formula here for you. So if you have f over g and then prime, then it becomes the derivative of the numerator multiplied by the denominator itself minus the numerator multiplied by the denominator, the derivative of the denominator, but divided by the denominator squared. So I want to apply this rule here. So, okay, my notation is not very good. So here, sine x will play the role of this f in the formula, and cosine x will play the role of this g in the formula. So what I will do, I will say that f prime of x is equal to the derivative of the numerator multiplied by the denominator itself minus the numerator itself multiplied by the derivative of the denominator squared, yes? Denominator squared. And leave it open, please. Thank you. Okay, but if you remember, what was the derivative of sine x? It was just cosine x. So the derivative of sine is cosine multiplied by an extra cosine here. The derivative of cosine is negative sine. Then divided by cosine squared. Okay, so cosine times cosine is cosine squared x. And then minus sine x times minus sine x becomes positive sine x squared. And then you have cosine x squared, yes. But this is a famous identity in trigonometry. It becomes 1. It becomes 1 over cosine squared x. So that is the formula that you can add to that table. So the derivative of tangent of x is 1 over cosine x squared, which of course you can write it as 1 plus tangent squared. So do you remember in chapter 2 we learned that 1 plus tan x squared is 1 over cosine squared. And usually if you want you can also write secant x squared. So all of them you will see in the university, but here you just need to know the first one, but they are completely equivalent. Sometimes it is useful to know that the derivative of tangent is 1 plus the function squared itself. Sometimes it is good to know that it is 1 over cosine squared. Sometimes it is good to know that this is secant squared. But this one, you don't have it in high school. And I don't think you will need that one. So that one is probably good. So you can add this formula in that list of the derivatives of the table. And of course, needless to say that if I have tangent of u, where u is a function of x, if I ask you what is the derivative of this, so you follow the same rule, so it becomes 1 over cosine u squared, but then because of the chain rule, you have to multiply it by an extra u prime. And I told you that you will never get these formulas in the test, you only get these ones. Any questions? So that was the last function that we will study its derivative in high school. Okay, if I want to give you an example, okay, let me start with this one. So we have f of x equals to 5 tangent to the third of 3x squared minus 1. So we want to find the derivative of this function. So what should I do? It is apparently clear that I cannot immediately use these formulas because this formula is only for tangent to power 1 of a function, but that is tangent to power 3, so I have to use the chain rule. And I hope that you have enough experience by now to realize that at this stage, taking the whole expression to be u is useful. Because if you do that, it becomes 5 u to the 3. If you go to scratch paper, you know how to differentiate it. It becomes 15 u squared, but because of the chain rule, you have to multiply by u prime. So then it means that I can differentiate it now. So it becomes 15 u squared, but this is u, so it becomes tangent of 3x squared minus 1 squared. But I have to multiply by the derivative of u, so I have to multiply by the derivative of this combination. And then I have to copy paste these parts. So it becomes 15 tangent of 3x squared minus 1 squared. And then I differentiate this using this rule that we learned today. So the derivative of tangent is 1 over cosine. So it becomes 1 over cosine of 3x squared minus 1 to the power of 2. But of course I have to give the role of u to this one now. And then I have to multiply by the derivative of u. And then if you just simply write this, it becomes 6x. I can multiply 6 here, so it becomes 90x tangent squared of 3x squared minus 1. And then you can divide it by this expression. So that is the derivative. Any questions? Okay, so I think let me solve some of these problems. Level 1 problems are easier, so I go to level 2 problems. Let me see. Let me solve some of them for you from the previous section as well. Okay, so let me solve this problem first. 40, 44. We can solve it together, by the way. So, problem 40, 44. So, the question is this. A function is given to you, f of x is e to power x multiplied by sine x, and then you are supposed to show that f double prime at 0 is equal to 2. This is the question mark. You want to show this. Okay, that's a very simple question that is on the level 1 problems, but it is good to know how to do this. So if I want to calculate this and show that this number is equal to 2, I have to differentiate this function 2 times. It means that I differentiate it, I get a function, then I differentiate that function once more, it becomes the second derivative. Yes, that is the second derivative. And then when the second derivative is found, you just replace x in the second derivative with 0 and calculate. Hopefully, if you haven't done any mistakes, I will get 2. Okay, so let us check that. So if I want to differentiate that, this is not something that you could do in Math 3C because that's a product of 2 functions. So I have to use the product rule. So do you remember? If I have f dot g prime, it is f prime multiplied by g plus f multiplied by g prime. So I have to use that rule here. So let me write all the details. Okay, so f prime of x becomes equal to the derivative of e to the power of x multiplied by the second function itself plus the first function multiplied by the second function derivative. Okay, I continue. So then it becomes the derivative of e to power x. You have it in the table. So then you know that this becomes the function itself and then multiplied by sine x. And then the derivative of sine x, you have it in the table, it becomes cosine x. So this is your first derivative. For the second derivative, I can do two different things. I can just take the derivative of this one, which is one product rule, plus the derivative of this one, which is another product rule, or you might prefer to factor e to power x out, then you have one product rule, yes? So that would be probably easier. So let me simplify that. I take e to the power of x out, then I will get sine x plus cosine x, yes? So this is my first derivative. The advantage of taking it out, because now if I ask you if I want to differentiate it once more, what should I do? You would say that this is exactly one product rule again. So I can use the product rule here. This is the product of this function with that function. So I have to use the same rule. So let me write the details in the future if you want to refer. So it becomes the derivative of the first part multiplied by the second factor itself plus the first one multiplied by the derivative of the second one. But you already know that the derivative of e to power x is just e to power x. And then the derivative of that part, you can just do it immediately, because the derivative of the sum becomes the derivative of the first one, which is cosine x, and the derivative of the second one, which becomes minus sine x. Of course, here they haven't asked you to simplify the derivative. You can just simply take x away everywhere and replace 0. Replace it with 0. So, but I would say that it is easier to simplify here in your head, yes? Because if I multiply this in e to power x times sine x, and if I multiply this, it will be the same with the negative sign, so they will cancel. And e to power x multiplied by this, e to power x multiplied by cosine, it gives me 2 of them, yeah? So it becomes equal to 2 e to power x cosine x. Now this is the second derivative, and now I want to calculate the second derivative at point 0. It means I replace x with 0 everywhere. But e to power 0 is 1. Cosine of 0, hopefully you know that that is also 1. So if you replace them, you get 2, and that is what is supposed to be done for this problem. Any questions? Okay. Okay, that is also let me do one problem. It is level 2 problem, but I think it's very simple. It's not that hard. Okay, so this problem is problem 4045. Yes. So I will solve one part of it. Let us solve part B. This function is given to you. Determine an equation for the tangent line to this graph. To the graph of this function. You have this function given, and you are supposed to find an equation for the tangent line to the graph of this function at point x equals to 1. Okay, so that's also a very standard problem. I don't know why they have put it in level 2 problem, but this is very simple. Yes, what we are supposed to do, I need to find the derivative of my function first. So the derivative of my function is the product rule, so it becomes the derivative of the first one, which is 1 multiplied by the second one, plus the first one multiplied by the derivative of the second one, but the derivative of e to power x is equal to e to power x. So that is my derivative. But then I ask you to find the k value for the tangent, yes? It means that I have to go here, replace the x values with the x coordinate of the point of tangency. So it means that this becomes e to power 1 plus 1 times e to power 1. This becomes 2e, yes? That is the k value, and then we are done. Of course, I need to, so I think if you remember this formula, that is better. So this formula is the 1-point formula for the equation for a line, for an equation for the line. So this, you have this. Okay, but x node here is just x equals to 1. I need to calculate y node here as well. So what is y node? It means that I go to my function, replace x with 1. So this becomes e. So I put them here. So this becomes y minus e is equal to the k value is 2e. And then you have x minus 1. And of course, usually, if you remember, we make y alone. So let me move it to the other side. So then this means that y is equal to 2ex minus 2e, but another e goes to the right, it becomes positive, so it becomes minus e. So this is an equation for the tangent to the graph of that function. Yes? Okay, so this problem, I want you to remind about that. So, problem 4049. A function is given to you. The function is y equals to e to the power of minus x sine x. You want to see how many extreme points this function has on the interval between 0 and 2 pi. And then you want to know the character of those extreme points, yes? What does it mean? It means that are they maximum or minimum, yes? Because you know that extreme points are a name that we give to max and or min, yes? So this is one type of those questions that you need to remember about your Math 3C lesson. I will try to find those videos related to this and I give you the link. So if you have forgotten, you can follow them. So if I want to find the extreme points of this function, do you remember what we are saying? Not for this function, for any function, if I want to find the extreme points, yes?
You think the derivative equates to 0.
To 0. But what you get are not exactly the extreme points, yes? What is the problem there?
Candidates.
They are candidates, yes? So you get max or mean or a terrace point. Yes, you remember? So a max point is this, because you know that when you put the derivative equal to 0, it means that the slope is 0. So you are looking for those points whose slope of the tangent line is 0. But if I have a max, this can happen. If I have a mean, this also can happen. I can also have a special case which we call terrace point. Here the tangent line here is again horizontal. So the tangent line horizontal, I have max. The tangent line is horizontal, I have mean. The tangent line is horizontal, I have neither max nor mean but the terrace point. Yes, the terrace point is a point at which the derivative is equal to 0, but the point is neither a max nor a mean. Yes, so that is 3 possibilities. So how should I find that? So I want to make the slope of the tangent line horizontal. So it means that I need to look for those points so that the derivative becomes 0. Okay? But how should I distinguish these 3 points from each other? So in this case, you see the function is going up and then returns back. But here it goes down and then goes up. Here this goes up and goes up again. It can happen this situation as well. It goes down and it goes down. So it means that for mean and max, the function is increasing, then decreasing. So for the mean, it is decreasing and then increasing. For the terrace point, in this case, it is always increasing. And for the terrace point, in this case, it is always decreasing. And you know that if the function is increasing, it means that the derivative is positive. If the function is decreasing, the derivative is negative. So by looking at the sign of the derivative, you can realize that. This is the content of the first derivative test. There is also another one which is called the second derivative test. And if you remember, let me talk about that later. Okay, so let me remind you of this. So I want to do this problem for this function. You were not able to do this in Math 3C because you didn't know how to differentiate this function. So how should I differentiate this function now? That is a product rule. So this becomes the derivative of the first one multiplied by the second one plus the first one multiplied by the derivative of the second one. Okay, so let us continue. So the derivative of e to power minus x is e to power minus x itself, but it is not finished by the chain rule. I have to multiply by the derivative of the exponent, which is minus 1. So let me write a minus because of that. And then multiplied by sine x. The derivative of sine is cosine. So that is my derivative. And usually, for these kinds of problems, it is better to simplify this as much as possible, because otherwise you have to work with a longer version of the derivative. So you see e to the power of minus x is in common, so I would prefer to factor it out. So y prime is equal to, if I factor e to power minus x out, from this term, cosine x is left. From this term, negative sine x is left. So this is the first derivative, yes? Okay, so now we have to refer to chapter 2 because we want to solve a trigonometric equation. So you see, you are not independent of chapter 1. So you have to know how to solve that equation because I want to put it equal to 0 and find x. But I have to work in this interval, yes? So this means that e to power minus x multiplied by cosine x minus sine x is equal to 0. But that is the zero product rule. A number multiplied by another number is supposed to be equal to 0. So either the first one is 0, which is not possible because exponential functions cannot be equal to 0. So this is always non-zero. or if you want to say, even if better, we can say it's always positive, it cannot be equal to 0. So this product becomes 0 if and only if this part is 0. So that tells me that cosine x minus sine x is equal to 0. Okay. Do you remember how to solve this from chapter 2? So you will get these kinds of questions in the national exam, because you see, if you want to solve this, you have to know a lot of things. First of all, you need to know the product rule to be able to differentiate. And then you need to be able to simplify a little bit. And then you need to be able to solve trigonometric equation. Yes? So how should I solve that? Any ideas? Yes?
I'm not sure if this is the only case, but when they are equal to each other, they should cancel out and become 0. And that happens for the case when x is 45.
Okay, 45 is not, yes, 45 is completely correct. It's one of the answers. But solving a trigonometric equation, it means that you have to find all the solutions. In this case, you don't need all the solutions. You need the solutions between 0 and 2 pi. But I want you to remember, because I want you to, there is no guarantee. They might ask you to find all the extreme points. So then you need to know how to solve the equation. In this case, 45, which you have to express it in radian, by the way. First of all, because you see 2 pi here. The second is that these formulas for the derivative of sine and cosine only works if it is in radian. So remember that, yes? So 45 is definitely one of them, which I can express. It becomes pi over 4, but there is one more. Yes, there is one more for it. So you need to know how to solve that. So the first thing, in this case, it would be easier if I divide by cosine. And this is guaranteed that cosine is not 0. Because if cosine is 0, this tells me that sine is 0. But this is not possible, because when cosine is 0, sine is either plus or minus 1. So I will be on the safe side if I divide by cosine. If I divide by cosine, this becomes 1. This becomes tangent. And this becomes 0. And then this means that tangent of x is equal to 1. Then I don't know, do you remember how to solve tangent? So what is in the box? K, x is what? Is a tangent inverse of 1. Tangent inverse of 1 is 45 degrees, as you mentioned. But plus n pi, where n belongs to z. So these are all solutions, and you see exactly as Jakub mentioned, the pi over 4 appears, but there is one more to it. Yes. So you need to find all these solutions on this interval. It is important because they might ask you find the extreme points on the interval between 0 and 4 pi, or they can ask you find all extreme points without giving you this interval. So you need to know how to solve the equation. Yes, and these are the all solutions of that equation. So how should I do that? I need to put integer values for n and find x. There is no hope. If I put negative values for z, for example, minus 1, minus 2, this becomes negative, but I don't want them because I want to confine myself to the positive ones. So the first number that I can put here is 0, and as you predicted, I get x equals to what? Pi over 4. And then, is there any other one? I put 1. It becomes pi plus pi over 4, which becomes 5 pi over 4, and it is still acceptable. I am in the interval, yes? So it becomes 5 pi over 4. And then if I ask you, can I put 2? Then I will be beyond that interval. So it means that these are the only ones. Yes? But you have to know how to solve this, because there is no guarantee they ask you only for these intervals. So these are the numbers. So if I ask you so far what are these, I cannot guarantee that this is max or mean. I cannot guarantee this is max or mean, because might be one or two of them, or I don't know, Neither of them are terrace points at this stage. Yes? So I need to find a character. Which one is max, which one is mean, and which one, if any, is a terrace point. For this one, you have two methods. Yes? One of them that I described there, it's a little bit lengthier, but it is always reliable and it always works. And that is, do you remember? So you need to have this sine table. So the first row is x. I don't need to go from minus infinity to infinity because I am only working on this interval. So my x values goes from 0 to 2 pi. And then I have two candidates. This number and that number, you have to respect the order. So the smaller one comes on the left and then the other one. And this middle line, if you remember by convention, it is the line for the derivative and the last line is the line for the function itself. Okay, and then my derivative is 0 if I am here or there. So it means that here the derivative is 0, here the derivative is also 0. Okay? And now for this part, I have to calculate the function for these values. So you go back to your function, this is your function. You have to put those numbers there. If you want to find the max or mean, I don't know which one they have asked, but let me solve it completely for you here. So this one, these are the candidates for the max and mean, but the y values are max and mean. If they don't ask for the max and mean, you don't have to calculate y. Yes? But let me just calculate, let us solve it completely. So I go back to this function and put pi over 4 here. So, but if I put pi over 4 here, it becomes e to the power of minus pi over 4. And then I will have sine of pi over 4. Okay, we don't need to calculate exactly. This is 1 over a square root of 2, so it becomes 1 over a square root of 2 e to the power of pi over 4. That's it. So you put that number here. I think in this problem they haven't asked you about this, but let me just write that. And then I put the same 5 pi over 4 here. Then you have another problem. You need to remember how to find sine pi over 5 pi over 4 exactly. So how can I calculate sine of 5 pi over 4? Yes? So this is e to the power of minus 5 pi over 4. But sine of 5 pi over 4, according to what you learned in part 2, chapter 2, it is pi plus pi over 4. And then sine of pi plus pi over 4 becomes negative of sine pi over 4. So this becomes e to the power negative e to the power of minus pi, 5 pi over 4 sine pi over 4. Yes? I hope that you know how to do this. Sine of pi plus pi over 4 is negative of sine pi over 4. So what you get at the end is negative 1 over square root of 2 e to the power of 5 pi over 4. So that is the number that I have to put here. Okay, for 0 it is very simple. If I put 0, sine of 0 is 0, so it becomes 0. If I put 2 pi, sine of 2 pi is 0, it becomes 0. So this is the complete form, so you don't need to be bothered about the details so much. Okay? And then you have to know where the function goes up and when the function goes down. So it means that in principle you need to know what happens. For this problem, I would say this is extremely hard if you want to calculate numbers in between. I don't know if this is in the part that you can use your calculator, you choose a random point between these two and put it in your calculator for the derivative. Be careful here. Yes, for the derivative. And then calculate that one. But I don't know, you need to convince yourself somehow. Then I will tell you how to cheat a little bit. So you don't need to know that. But here, if I want to know the derivative is the product of two parts. This part is always positive, so I don't need to be worried about here. If cosine is greater than sine, the whole product becomes positive. If cosine is less than sine, the whole product becomes negative. And now imagine a little bit, if I am between 0 and pi over 4, which one dominates, cosine or sine? So you can, this is not hard, you know. This is, if I draw this is pi over 4 exactly. If I am somewhere between 0 and pi over 4, you know cosine is the x-coordinate and sine is the y-coordinate. If I am below this, it is clear cosine is bigger than sine. And if cosine is bigger than sine, this is positive and this is also positive, so it means that this product is positive. Yes? Okay, but of course you need to, where is 5 pi over 4? 5 pi over 4 is exactly the opposite. So what happens, do you think, between pi over 4 and 5 pi over 4? Which one dominates, cosine or sine? So if I am from here up to here, which one will dominate? So if I am from here to here, of course sine is greater than cosine, so this becomes negative. If I go to this second quadrant, sine is positive, cosine is negative, again this is negative, and for the same reason you can convince yourself this is also negative, so it becomes negative all the way around. And then after that it becomes, it becomes negative, and then after that it becomes positive. So this means that this function increases here, decreases here, and then increases here. This is the real way to do it, because first you need to know the notion of the derivative. But of course, this function is a well-behaved function. By a well-behaved function, I say this is a continuous function, because e to the power of minus x is continuous, the curve is continuous, and the sine function, you already know it's continuous, and the product of two continuous functions is a continuous function. So you really don't need to bother about making this thing here. So the y value is 0, and it has reached to this value. Do you think it has increased or decreased? This number you don't need to calculate. This is definitely a positive number, yes? The value was 0, now the value is this positive number. So it is clear that the function should increase. So logically, you have to determine the signs first and then see where the function goes up and down. But you can cheat a little bit and do it the other way around, yes, because this function is a well-behaved function. But if you go to university and then you get some functions which are not continuous, you have to do it in a proper way, yes. But here, without these signs, I can immediately see that the function is increasing here because the value has reached from 0 to this, and now the value is positive and it has reached to a negative. So it is clear that the function has gone down, has gone down, and then the function again from a negative value reaches to a positive value, so the function goes up. So you just do this one first and then put the signs. Yes, that is also possible in this case. But anyway, this point you see here, and this point, were the candidates of max and mean points. And now you realize they are real, they are not fake ones, yes? It goes up and down, so this point is a max point. It goes down and then up, it's a min point, yes? So I would say that there are two extreme points for this function, 5 pi over 4 and this number is max point, local maximum point, and then you have 5 pi over 4 and negative 1 over square root of 2e to the power of 5 pi over 4 as your mean point, local minimum point. So then I ask you, then you need to be careful. If they ask you for the point, you have to write both x and y coordinates. If they ask you where this happens or where these max and mean are attained, you just express the x values. And if they ask you what is the local maximum, then you need to give the y value or the local minimum. Yes? If they ask you about the value, that is the y value. If they ask you about the point, you have to write both x and y coordinates. And if you are asked where this is attained, they are asking you about the x coordinate. So in this case, there are no terrace points at all. Yes? So these kinds of questions, you need to remind yourself. Let me try to see if we can do it another way. I want to remind you about another test. So this is, what you see here is the first derivative test. And because when I want to apply it, I only need the first derivative. Yes?
Can I say the next, how you're supposed to do the second part?
Yes.
So you take the second derivative and then you put in this x values. If the second derivative gives you a negative value, then you have a max point. If it's a negative value, then you have a min point. And so
and there's something more to it. Because you might be unlucky and you get 0. Yes? Then what happens, unfortunately, the method doesn't work. So you need to know about that, okay? So if you are lucky, so let me just follow, exactly. So the second derivative test content is that if I want to find the character of these points, I calculate the second derivative. So let us just do it step by step. But of course, it depends how fast you are in calculating the second derivative. And by the way, second derivative here is easy. But assume that you have a fraction, the first derivative becomes a little bit of mess, and then you want to do another one that becomes harder. So you need to decide which one is suitable for the problem in your hand, yes? So here I think it's easy. So let us just do the second derivative. So let me change my color. So this is not, so this problem is finished here in this way. You don't need to solve it in 2 different ways, but let me just do it once more by second derivative. That's a product of 2 functions. The derivative of the first one is minus e to power minus x multiplied by the second one itself. And then plus the first one multiplied by the derivative of the second one. The derivative of cosine is negative sine. The derivative of sine is cosine. So I will get 2 negative signs. And then I will factor e to the power of minus x out from here and there. But this minus sign is left, it goes in, it becomes negative cosine, and it becomes plus sine. Here I have negative sine, negative cosine. Yes? And then you see that this one and this one are cancelled. Minus cosine is minus 2 cosine. So finally I will get my second derivative. Second derivative is minus 2e to power minus x cosine x. So I think in this case, it is better than using it in this way. Because first of all, the second derivative was not that hard, and the form of the second derivative is actually very friendly. It's similar to the function itself, yes? But be careful. For the second derivative test, this part you have to do again. Yes? So you have to do for the second derivative test, everything that I have done here, you have to do it. Because you have to find your candidates. Yes? But instead of drawing this table and then try to convince yourselves about the signs, you can alternatively use the second derivative test. So the second derivative test share everything up from here to here. And now, what I have to do, let me do it here. So what I can do now, I take, for example, pi over 4 and put it in the second derivative. So y double prime at pi over 4, I should not calculate. You have to only convince yourself if it is positive or negative. You really don't need to calculate the number. So here it becomes minus 2. And then I have e to the power of minus pi over 4, and then I have cosine pi over 4. So is it positive or negative? This is definitely positive because it is in the first quadrant. Exponential function is positive, and this one is negative. So then it is clear that this is negative. So the y double prime of pi over 4 is negative. When it is negative, it means that the point that corresponds to pi over 4 should be a max point. So you need to remember. A negative value for the second derivative indicates that the point corresponding to that is a max. If the second derivative is positive, it indicates that the point corresponding to that is a mean point. And this is unfortunate. This can sometimes happen. When you calculate the second derivative, it becomes 0. When it becomes 0, everything is possible. So this means that you have spent a little bit of time in calculating the second derivative, but for that point it is useless. You have to go back to the first derivative test. So then, of course, you have to decide which one is suitable for you. So then I calculate the second derivative for 5 pi over 4. So this becomes minus 2e to the power of minus 5 pi over 4 cosine 5 pi over 4. Again, 5 pi over 4 is in the third quadrant. Yes? So this cosine in the third quadrant is negative. But this is always positive. And this is negative. So this means that this is positive. So this, as you see, this is confirming exactly our previous calculations. So is that clear? So the first part you have to do it again. But instead of going to the table, which is called the first derivative test, and is more powerful. Because in the first derivative test, you don't need to be worried about these exceptional cases if it becomes 0. So it will always work, but of course the price that you have to pay is to draw that table, which is long. And that is not always bad, because if a function is a bad function, calculating the second derivative becomes harder. So then you need to find a balance. Which one is suitable for that problem? That is up to you to decide. But this is more or less a crash course about those things that we have done. Yes? So this is something that you really need to know. Okay, let me see if I am missing something or not. Yeah, I think this is more or less the content. I will find the videos that I was teaching these concepts. If you have forgotten me more, I will put the links in Google Classroom. Okay, let me move to the other part. Let us see how it will work with some of these problems. Yeah, so let us for example, this one is 4059. It's talking about terrace points. Let me solve that one as well for you. This problem is 4059. Show that this function has a terrace point and determine its coordinates. The function is this one. F of x is equal to this quotient x cubed divided by x squared plus 1. So here we want to show that this function has a terrace point. Okay? So what I have to do, again the same thing. I have to calculate the derivative, put it equal to 0. Might be I get some candidates. If there is only one candidate, and if this problem is correct, it means that I have to confirm that this is actually the terrace point. If there are more than one point, then I have to decide which one is the terrace point as well. Yes? So what I have to do, I have to take the derivative. But let me write the formula here. If you have a fraction and you want to differentiate it, it becomes the derivative of the numerator multiplied by the denominator minus the first one multiplied by the derivative of the denominator squared. So I use that rule here. Because there is no way, because I told you that, remember this. If you can avoid this, avoid that. When you can avoid that, if the denominator contains one single term. If that contains one single term, it is better to avoid that by the methods that I have already described that for you. But here, if I want to do it, then I would say this is the only way to do it. So it becomes the derivative of the numerator multiplied by the denominator itself minus the numerator itself multiplied by the derivative of the denominator, but divided by the denominator squared. Don't forget about squaring it. Oops, this is wrong. This is prime. Yes. Okay, so now this becomes the derivative of this one is 3x squared, and then I have x squared plus 1. The derivative of this, it becomes x to the power of 3 times 2x. And then I have x squared plus 1 squared. you have to, you see, for differentiation, this is finished. But in these problems, you have to simplify them. So then I multiply this in, so it becomes 3x to the 4 plus 3x squared. And then I have minus 2x to the 4. And then I have the denominator, x squared plus 1 squared. And if I simplify that, finally I have my derivative here. The derivative is this number minus that one, it is x to the power of 4. And then I have 3x squared here. And then you have this. Okay, so this is your derivative. Okay. This is your derivative. So the next step is to put the derivative equal to 0 and find x values. But the derivative is a fraction. And a fraction becomes 0 if and only if its numerator is equal to 0. So this means that this, I want you to remember, if I want to equate a fraction equals to 0, I have to be careful. The numerator should be equal to 0 and the denominator shouldn't. But of course the denominator is not 0 because x squared plus 1 is always positive. This means that I have to equate the numerator to 0. And then you need to know how to solve this but this is very simple. Even though it is a 4th degree equation, but you can simply factor x squared out. So this becomes x squared plus 3 equals to 0. Okay, but this is, so you have only one candidate. Yes, because the zero product rule tells you that either this one is 0 or that one is 0. But this cannot be equal to 0 because x squared is non-negative. And when I add 3 to it, it is always positive. Yes. This one is always positive. And if I want to make the product equal to 0, I have to make the first one equal to 0. This means that x squared is equal to 0, then this means that x is 0. So, but here I cannot say that this is definitely a terrace point. It might be a max, it might be a mean, or a terrace point. So if you just stop here and say that, okay, there is only one candidate and according to the problem it should be a terrace point, it is not correct. So you have to convince that this one is not a max, not a min. It is definitely a terrace point. So how should I do that? So here, so the second derivative doesn't work here. And even if it works, it is harder to do the second derivative here. So then I have to go and convince myself that happens. But you really don't need to draw any details because in this question, what you want to convince yourself that what is happening close to this point. Yes. So if I want to do that, I do not draw the whole table. Yes. What I do, I will do this. So I will say that this is x. I don't know. I have the candidate here. I know the derivative is 0 here. If you want to, you can put the 0 in the function. Coincidentally, the function also becomes 0 there. Everything is 0 here. But then, what is the sign of the derivative? This is your derivative. By the way, in the numerator, I could easily factor x squared out. Why I'm doing this? Because if I want to know the sign of something, if that is a product, it is easier. Yes? So I would do it like this. Yes, this is 3. And then I have x squared plus 1 to the power of 2. So by the way, what is the sign of this derivative? It's very simple, by the way. You really don't need to discuss anything, yes? Independent of my choice of x, the numerator is always positive. The denominator is also positive. So it doesn't matter if I am on the left-hand side or I am on the right-hand side. This is positive and positive. So it means that derivative, this is positive, so the function is increasing before 0. It continues to increase after 0 as well. So it means that this is a terrace point. Yes? A terrace point of this type. Because terrace point could be of this type or of this type. But this one is of this type because it's increasing. So this confirms that the origin is a terrace point for this function. Yes? So that is also good to remember. Okay, so I think that's a good review for these things. Everything is more or less done in this chapter. So I will stop today right here, but then I will continue to the next chapter on Friday and Tuesday, okay? And then I will give you some time to practice for the test here after the January, okay? In the January, actually. And we can decide about a good time for the test, yes?
Can't we decide now?
From now it's a little bit hard for me, of course, if you have any...
Because we have a physics test in week 3.
Yeah?
And I think we're going to have a biology test around week 4. If not earlier.
So we can make it week 2, yes?
Yeah,
Is
that's what
that
I was
okay?
thinking. Otherwise it's just going to be...
I don't know, but if I make it week 2, which week we come back to school? Week 2, yes? Then it means that you have to worry about your exam all the time and your holidays. I don't need to be worried anything, so if you want I can do that. Because the next chapter is integrals. Okay, so let me see if we can divide this. Yeah, we can do this. I can continue teaching, okay, and then when we reach to the middle of the next chapter, we will have a little bit bigger test.
Oh, no.
Okay, let's just decide after the break.